Hi, 8th grade. Welcome to lesson 5.3, Solve Systems by Substitution. By the end of the lesson, I want you to be able to say, I can solve systems of equations using substitution. Let's explain it. Jackson needs a taxi to take him to a destination that is a little over 4 miles away. He has a graph that shows the rates for 2 companies. Jackson says that because the slope of the line that represents the rates for on-time cabs, the blue one, is less than the slope of the line that represents Speedy Cab Co., the cab ride from on-time cabs will cost less. Part A. Do you agree with Jackson? Explain. Part B. Which taxi service company should Jackson call? Explain your reasoning. Okay, do you agree with Jackson? I say that I don't agree with Jackson because it depends on how far he is going. So it depends on distance. Because the on-time cabs has a lower slope, but if you're going a shorter amount of time, like anywhere, or shorter amount of distance, anywhere from about 0 to 4, on time is actually more expensive. After 4, on time is less expensive. Before 4, Speedy Cab is less expensive, and then after 4, Speedy Cab is more expensive. But Justin wants to do 4 miles away. So at that point, Justin could choose either. They will cost the same at that distance. Right here, a little over 4 miles. So he can choose either, maybe whichever one comes sooner. Can you use the graph to determine the exact number of miles for which the cost of a taxi ride will be the same? Explain. Yes. It is the solution to the systems of equations. Systems of linear equations. So last lesson we were talking about finding the solution by graphing. Today we're going to do it algebraically by substitution. So example number 1. Gemma sells tickets at a local fair. On Saturday she sells 800 tickets and collects $7,680. How can Gemma determine the number of each type of ticket that was sold on Saturday? Well, adult tickets are $13.50, and children under 12 are $7.50. So what we're going to do is we're going to write two types of tickets, or 2 types of equations. We have an equation that tells us the number of tickets, and we have an equation that talks about the money. So first, this first equation here, the number of children's tickets plus the number of adult tickets is equal to 800 total tickets. We get that from the beginning, 800 total tickets. There were children and adults. There were no other types of people buying the tickets. Then it's $7.50 for a child, so it's going to be $7.50C. And it's $13.50 for an adult, $13.50A. That's going to talk about the price of the ticket. When we add those together, it's the total price, the total amount of money that she made. So now we have our 2 equations. So that's step 1. Step 2 is to solve for one of the variables, to get one of the variables alone. It does not matter which one. In this case, it's just as easy to solve for one or the other. In their example, they solved for C. So to get C by itself, they subtracted A from both sides. So that cancels, and we get C equals 800 minus A. So if C equals 800 minus A, wherever we see a C in that second equation, we can put 800 minus A. So instead of 750 times C, we put 750 and then 800 minus A in parentheses. And then rewrite the rest of the equation just like normal. Then we use our steps of substitution. I'm sorry, not substitution, but distribution. Remember, to distribute means to multiply. So 750 times 800 gives us 6,000. 750 times negative a is negative 750a, and bring down the 1350a. Now we can combine like terms. So negative 750a plus 1350a gives us 6a. And they also did this in one step, but they got 6,000 on the other side by subtracting 6,000 from both sides. So it cancels out on the left, and we get 6a equals 1,680. To solve for a, divide by 6 on both sides. Cancels out, and a equals 280. So now since we know a is equal to 280, meaning there are 280 adults, we can plug that into the original equation talking about the number of adult tickets versus children's tickets and solve for c. So c plus 280 equals 800, so we're going to subtract 280 from both sides. This cancels out, and c equals 520. So there are 520 children's tickets and 280 adult tickets. That is our solution. All right, let's try it. Brandon took a 50-question math exam worth a total of 160 points. So there are 50 total questions worth 160 points. There were X 2-point questions and Y 5-point questions. How many of each type of question were on the exam? So X plus Y, the number of X questions and the number of Y questions is equal to that total, that 50. And then talking about the points, X questions were worth 2 points, Y questions were worth 5 points, and they got a total of 160 points. So remember, the first step is to solve for one of the variables. So they set it up so that we solve for y. So using that first equation to get y by itself, we need to get rid of the x's. So subtract x, cancels out on the left, and we get 50 minus x. Now we're going to take the fact that y equals 50 minus x, and wherever we see a y, we can put in 50 minus x. So they rewrote that second equation, 2x plus 5, and now instead of y, we're going to put in 50 minus x. Now we're going to use what we've learned and distribute the 5. So the 2x just gets brought down. 5 times 50 is 250. 5 times negative x is negative 5x. Now, combining like terms, we get 2x minus 5x equals negative 3x plus 250 equals 160. Trying to get my x's by itself, I'm going to subtract 250 from both sides. This cancels out. I get negative 3x equals, looks like negative 90. Divide by negative 3 on both sides. This cancels out. X equals 30. So there were 32-point questions, but that's not the end of the question. They want to know how many of each type. So there are 32-point questions. So now going back to that first equation, x plus y equals 50. Instead of x, we can put 30. And now x plus y equals 50. That means y must equal 20. How do you know which equation to choose to solve for one of the variables? Whichever has a variable with a coefficient of 1. That will always make it easier. We'll have to do less steps. Okay, example number 2. Use substitution to solve a system with no solution. Seiko takes pottery classes at 2 different studios. Is there a number of hours for which Seiko's cost is the same at both studios? Write a system of linear equations to represent the situation. Let x be the total number of hours and y equals Seiko's cost. So this first one is $14 per hour. So that's where they get this first equation, 14x. Second equation is 28 per hour plus $15 for clay. But if you use the coupon, it's half off. So that's where they get the 28x plus 15, but they multiply it by 1/2. Now here, they have y equals and y equals. So we can substitute the y's for each other and actually just set them equal to each other. So 14x equals 1/2 times 28x plus 15. Distributing in that 1/2 gives us 14x equals 14x plus 750. Trying to solve for x, you're going to subtract 14x from both sides. They cancel out, and 0 equals $7.50. That doesn't make any sense. This result is not a true statement, so the system has no solution. There is no number of hours for which Seiko's cost is the same at both studios. Example 3, use substitution to solve a system with infinitely many solutions. So solve the system 2y minus x equals negative 8491, and 3x plus 6y equals 254 plus 73, using substitution. So we know we have to substitute it in. So the first step, solve one of the equations for a variable. So this first equation, they're trying to solve for x. So they add 2y to both sides. Cancels out on the left. We get negative x equals negative 84.91 plus 2y. X is still not alone. We got to divide by negative 1 on everything. So that equals x equals negative 84.91 divided by negative 1 equals positive, and a positive divided by negative equals negative. So now we know that x equals 84.91 minus 2y. So wherever we see an x in the other equation, this 3x plus 6y equals 254.73, we can plug that in. So we do 3, and then instead of x, we put what we just found, that x equals 84.91 minus 2y. Distribute the 3 in. So then 254.73 minus 6y plus 6y equals 254.73. Combining like terms, negative 6y plus 6y, those are opposites, so they cancel out. We get 254.73 is equal to 254.73. That is always true. The result is a true statement. The system has infinitely many solutions. Use substitution to solve each system of equations. Explain. So the first equation, y equals 1/2, y plus 1/2 x equals 3. I'm going to solve for y, trying to get y by itself because that will be the easiest. This cancels out. Y equals negative 1/2 x plus 3. So now with my second equation, 4 times y, well, I just found out that y equals negative 1/2 x plus 3. So instead of y, I'm going to put in negative 1/2 x plus 3 and write the rest of that equation. Plus 2x equals negative 6. Now I distributed my 4. 4 times negative 1/2 is negative 2x. 4 times positive 3 is positive 12. Plus 2x equals negative 6. Combine like terms, negative 2x plus 2x. Those are opposites. They cancel each other out. And we're left with 12 equals negative 6. Is that true? No. There is no solution. Last question. Y equals 1/4 x minus 2, and 8y minus 2x equals negative 16. They already did the first step for us. They already told us what y equals. So I'm going to rewrite that second equation, but instead of y, I plug in 1/4 x minus 2. Rewrite the rest of the equation. Distribute. 8 times 1/4 x is 2x. 8 times negative 2 is negative 16. Minus 2x equals negative 16. Combining like terms, 2x minus 2x, again, opposites, they cancel out. Negative 16 equals negative 16. That is always true. There are infinite solutions. All right, 8th grade, let's say it. I can solve systems of equations using substitution. Have a great day.